Hi, and welcome back to the good stuff we have been doing. Today in this video, we'll have this interesting integral. Okay, so please go grab your popcorn because this is by no standard easy. It does look easy, so I'll call it deceptively difficult because it does look like something you can maybe try integration by parts, try substitution. Although one substitution that works here would be x equals to, let's say, 1 minus x over 1 plus s, which is the so-called Mobius transform. But then if you follow this approach, you're going to end up with, I think you're going to get, when s is 0, you get 1. When s is 1, you get 0. So you're going to end up with 0 to 1. You're going to have a logarithm of 1 minus x plus x squared, all divided by 1 plus s squared. So again, you are going to end up with an integral that is, though you can still do something here, but again, none of these steps are easy to even wrap together. So whatever you do, there is no easy way out of this integral. There's nothing to do rather than suffer. So let's suffer and see if we can see if there's a meaning in our suffering. So what we're going to do is that we're going to use the formula that the logarithm of 1 plus x, logarithm of 1 plus ax is equals to the integral from 0 to a of x over 1 plus xt. So having that in mind, you have that the integral from 0 to 1 of the log, our integral, which is log of 1 plus 3x squared, all divided by 1 plus x squared dx. This equal the integral from 0 to 1 of 1 over 1 plus x squared. Now, this log of 1 plus 3x squared, we could write it as the integral from 0 to 3. Using the formula we have derived here, integral from 0 to 3 of what? X squared all divided by 1 plus x squared t dt, then dx. So we replace this entire log by this integral. May look like a backward thing to do because it's more like as if we are complicating the expression, but we're actually doing something to simplify it. So let's work with this. Now we have this to equal the integral from 0 to 1 times the integral from 0 to 1 of what? So you have an x squared divided by 1 plus x squared and 1 plus x squared t. Okay, that is not, this is 0 to 3 rather. dt dx. Now what next? Well, what we need to do now is to put everything in partial fraction. So we need to like put x squared divided by 1 plus x squared and 1 plus x squared t in partial fractions. And I've already done this, so no need for you to worry yourself. So this will be equals to the integral from 0 to 1 times the integral from 0 to 3 of what? You have a t minus 1. So 1 over t minus 1. Then it multiplies on the first part. You have 1 over 1 plus x squared. So subtracting 1 over 1 plus x squared t. Now, when I was solving this integral, the thing that crossed my mind is this t minus 1. This t minus 1 is going to make this problem more difficult than it should be because there is a singularity here. If we integrate with respect to 1, you will get a 0. So it will make this problem more complicated than usual, but we don't have any choice but to try to make meaning out of this. So if we continue in this fashion, you're going to have to do the integral from 0 to 3 of 1 over t minus 1 times what? The integral from 0 to 1 of 1 over 1 plus x squared dx. Okay, now we're going to subtract it from the integral from 0 to 1 of 1 over 1 plus x squared t dx. Then you have the t. Notice that I switched the order of integration whereby instead of dt I did dx, and for that reason I have to carry this 0 to 3 back and 0 to 1 at the front here. So but let's see, continue. Now let me reduce the screen size. Okay, yes, so I have more space to work with. So now this equal the integral from 0 to 3 of 1 over t minus 1. Now inside here, this is basically tan inverse of x, and we're evaluating this from 0 to 1. And then over here, this is if you remember the formula for tan inverse, I've used it a lot on this channel. It says that tan inverse of x is equals to the integral from 0 to 1 of x over 1 plus x squared t squared dt. Yeah, so basically this will be tan inverse of square root of t. This will be tan inverse of square root of t, all divided by square root of t. So we're going to divide this by square root of t. So dt. Now we have this to integrate. If you don't know what's happening, you may think that we're making progress, but though we're making progress, there's still a lot of work to be done. So this is integral from 0 to 3 of 1 over t minus 1. Then you have, this is tan inverse of 1, which is pi over 4. So you have a pi over 4 minus, still tan inverse of square root of t over square root of t dt. Now we have a pi over 4 times the integral from 0 to 3 of 1 over t minus 1 minus the integral from 0 to 3 of what? Tan inverse of square root of t, all divided by tan inverse of square root of t, all divided by square root of t times t minus 1. So dt, of course, dt. Now this would be equal to, you would have pi over 4, then you would have the logarithm of the absolute value of t minus 1 as we take this from 0 to 3, then minus, then you should have the integral from 0 to 3. Now before having the integral from 0 to 3, how do we deal with this square root of t here? So you can take actually x to be equal to square root of t, and we know that dx would actually be 1 over 2 square root of t dt. So basically it's 1 of dt divided by square root of 2 square root of t would be 2 dx. So at this point here we have 2 dx. So what about when t is 0, you get 0, and when t is 3, you get square root of 3. So you have tan inverse of t of x, all divided by, so here you have now t will be, so you have a t squared minus 1, so you have a t squared, x squared minus 1 rather, because t would be x squared, so you have an x squared minus 1 dx. I believe so, because yeah, t minus 1, you have x squared minus 1, and this yes, twice, of course, then everything will be equal. So this is going to be pi over 4 times the logarithm of 2 minus, so we have the integral from hope there's no mistake from our side there. So x is square root of t. So s is, yes, there's no mistake, everything is in good shape. So but this would not, this integral now is what we have to worry about. Integral from 0 to square root of 3 of tan inverse of, this is twice the integral from 0 to square root of tan inverse of x, all divided by x squared minus 1 dx. So let's focus on it. Let's focus on this integral here. One thing we can do for this integral here is this. We could observe that because of this square term minus 1 and this x, we can take Mobius transform. We can take x to be 1 minus t over 1 plus t. And the reason for this is because it may look like the argument of tan inverse would become complicated, but not really, because in this case, we would have tan inverse of 1 minus t over 1 plus t, which should be pi over 4 minus tan inverse of t. So that should save us, and at the bottom things should not be too messy. So let's try this out. So let's start with the integral from 0 to square root of 3 of tan inverse of x, all divided by x squared minus 1 dx. Okay, so if you take x to be 1 minus t over 1 plus t, we can find the limit of integration when t is I think when Okay, that means t here would be 1 minus x over 1 plus x. So when x is 0, t will be 1. So the integral here would start from 0, would start from 1 to when x is square root of 3, t will be 1 minus square root of 3 over 1 plus square root of 3. And then we could multiply the top and bottom by 1 minus square root of 3. We could have 1 minus square root of 3 and 1 minus square root of 3. So we should have at the top 1 minus 2 square root of 3 plus 3, and then at the bottom we should have 1 minus 3. So this will be 4 minus 2 square root of 3 all divided by negative 2. So we can cancel out the 2. So that will be 2 minus square root of 3 all divided by negative 1. So that will be square root of 3 minus 2. So we have square root of 3 minus 2. Notice that square root of 3 minus 2 actually is negative number. So keep that in mind. Square root of 3 minus is because square root of 3 cannot be bigger than 2. Okay, so now this is going to be tan inverse of 1 minus t over 1 plus t. And the bottom part, you have a 1 minus t over 1 plus t, all square minus 1. Now the dx would be negative 2 dt all divided by 1 plus t squared. So keep that in mind. You can always verify this, but if you have done any math with Mobius transform, you should know that this is automatic. Yeah, there's nothing to verify here. We all know the derivative on that aspect. But then this would equal the integral from negative times the integral from 1 to square root of 3 minus 2. Then this would be pi over 4 minus tan inverse of t all divided by, now here this would then be 1 minus t squared, which is 1 minus 2t plus t squared. This will be subtracted by 1 plus 2t plus t squared all divided by 1 plus t all squared. Then you have, okay, let me say negative 2. Then you have dt over 1 plus t squared. Eventually this will cancel out with each other. Now the bottom part, how do we simplify? You have a 1 minus 2t plus t squared, subtracting 1, then you have a minus 2t, the minus t squared. So they cancel out, and you have negative 4t. So this will be negative 2 times the integral from 1 to square root of 3 minus 2. Then you have pi over 4 minus tan inverse of t all divided by negative 4t dt. Now you see the miracle here. So now we no longer have to worry about the s squared minus 1 at the bottom. And even though we have a t here, you know, if you have a t, you tend to be worried because if the integral from 1 over t dt would equals to log t, but then in this case the limit of integration starts from 1, not from 0. If we had a 0 here, we would have been worried. So now we can continue peacefully. So this will be the integral from 1 to square root of 3 minus 2 of pi over 4 minus tan inverse of t all divided by, now 2 cancel out, you get 1/2 all divided by, and also there was a 2 here. Okay, that 2 is what cancelled out 2 as well. Let me check. Yeah, so you have half all divided by t dt. Now we can take it, this will be half of the integral from 1 to square root of 3 minus 2 of no, this is pi over 8, pi over 8, yeah, pi over 8. So 1 over t dt. Now in this case, now you see how 1 over 2 times the integral from 1 to square root of 3 minus 2 of, then you have tan inverse of t over t dt. Now we have really simplified our problem because you could see that this first one is evident that this is pi over 8. Then you would have the logarithm of the absolute value of t at t runs from 1 to square root of 3 minus 2. And this part here, you have half of, okay, let's do integration by parts. So you have log t here, then you have tan inverse of t, for this from 1 to square root of 3 minus 2. Then you have to subtract this from half times the integral from 1 to square root of 3 minus 2 of what? Now you have to take the derivative of tan inverse, right? So that would be log t divided by 1 plus t squared dt. Okay. So this would equal log, this is pi over 8 times the logarithm of 2 minus square root of 3. Keep in mind that the reason we are doing this is because if you take the absolute value of square root of 3 minus 2, you have 2 minus square root of 3, okay? So this will be plus. Now, if you plug in this, you will have 1 over 2 times what? The logarithm of 2 minus square root of 3, and then times tan inverse of square root of 3 minus 2. Then minus, now if we are going to make substitution, because we are going to take t to be tan. So if you take t to be tan theta, then dt would be, then dt over 1 plus t squared would be equals to d theta. Okay, now when t is 1, you have pi over 4. So this is going to be half times the integral from, let me write it, from pi over 4. Now when t is square root of 3 minus 2, that should be negative pi over 12. So negative pi over 12. Then you have logarithm of what? Tan of theta d theta. Okay, so let's see. So this is pi over 8 times the logarithm of 2 minus square root of 3 plus, no, this will be minus, so this will be minus 1 over 2, right? Minus, this is pi over 12, so minus pi over 24 times the logarithm of 2 minus square root of 3. Okay, now you have a minus 1 over 2 times the integral of pi over 4 to negative pi over 12 of logarithm of what? A logarithm of tan theta d theta. Now we can now focus on this last integral. Let's call it j. J being the integral from pi over 4 up until negative pi over 12 of what? The logarithm of tan theta d theta. So how do we evaluate j? Well, it will not be too difficult to evaluate, but first of all, you understand that it can be done via Fourier series, but we can't do it in this particular video, but I will do it in the next video, because at some point we're going to get to meet integral from 0 to pi over 12 of logarithm of tan theta, and this is equals to negative 2 over 3g. Now this is very difficult to evaluate on its own right, but I have solved this on my Twitter page using 2 different methods. So yeah, I'm going to merely quote the results, and in the next video I'm going to make a video about it. So here now we will have the integral from pi over 4 to 0 of logarithm of tan theta, then d theta, then plus the integral from 0 to negative pi over 12 of logarithm of tan theta d theta. Now here this is negative times integral from 0 to pi over 4 of the logarithm of tan of theta d theta. On the other hand, this part you can plug in theta to negative theta. You would have d theta negative, yes, so you would have minus the integral from 0 to pi over 12 of logarithm of tan of theta d theta. Now this is well known. This is g. This is negative times negative g. On the other hand, this one here is still not all that known, but I've quoted the value to negative. So you have a negative of negative 2 over 3 times g, where g is Catalan's constant. So you would have a g plus 2 over 3g. So that would be 5 over 3 times g. So essentially now our integral, let's see, our integral will be pi over 8 logarithm of 2 and square root of 3. So our integral, which is the integral from 0 to 3 of tan inverse of square root of t all divided by square root of t and then t minus 1 dt. So that would be pi over 8 times the logarithm of 2 minus square root of 3. And then what next? Minus pi over 4. Okay. Pi over 8 minus pi over 24. Let me calculate this with calculator real quick. I don't want to crack my head. I've already done too much. Let me check. You have 1 over 8 minus 1 over 12. No, 1 over 24. 1 divided by 8 minus 1 divided by 24. So that is pi over 12. So you have pi over 12. So you have plus pi over 12 times the... No, so this is pi over 12 rather. This will be pi over 12 here. Okay, pi over 12. Okay, now minus 1 over 2. Okay, minus half times 5 over 3g, which is pi over 12 times the logarithm of 2 minus square root of 3 minus 10 over 6g. Okay, now let's start. Then the original integral, which is the integral from 0 to 1 of logarithm of 1 plus 3x squared all divided by 1 plus x squared dx, we got pi over 4. Let me see. Okay, pi over 4 log 2 minus twice this integral. Okay, yes. We got pi over 4 times log 2 minus twice the integral from 0 to 3 of tan inverse of square root of t all divided by square root of t times t minus 1 dt. So this will be pi over 4 log 2 minus twice of pi over 12 times the logarithm of 2 minus square root of 3. Then okay, no need to close the gate yet. So this is minus plus 5 over 10 g. Okay, so this will be pi over 4 log 2 minus pi over 6 logarithm of 2 minus square root of 3 minus 5 over 3g, or this will be pi over 4 logarithm of 2. Yes, so this will be plus pi over 6 logarithm of 2 plus square root of 3 minus 5 over 3g. But I want to check if everything is correct. Let me check the problem. Oh, I'm getting pi over 3 here. Probably a mistake somewhere from our addition of the log part. Yeah. Okay. All right, so let me see. Maybe if I add 1 over 8 and 1 over 24 to it, should be, let me add and see, 1 over 8 minus 1 over 24. I got 1 over 12. Yeah, there is a little bit of algebra, but the answer is probably is pi over 3. The algebra is here is the issue, but the answer is pi over 3. Yeah, I think it should be pi over 3. So this will be pi over 4 log 2 plus pi over 3 logarithm of 2 plus square root of 3 minus 5 over 3g. That is the correct solution. So thank you for watching, and please do subscribe to the channel. Bye.